Welcome everybody again for our already the 5th webinar from the Energy Delta Institute. Today, together with the Energy Academy, I'm joined here today with a senior research fellow from the TU Delft, Theo Vens. Welcome, thank you that you're here.
Yep.
We're going to discuss the spatial aspects of the energy transition. So we'll discuss a little bit about how this evolves, especially in the Netherlands, but we'll discuss also a little bit about the European perspective, I believe. For the Energy Academy students, welcome and nice of you to join us. Again, just like last time, after this lecture, you will get a questionnaire that you have to answer. So otherwise you won't get your points. So pay attention to Theo and to me, and I think it will be all right. So Theo, oh yeah, one more thing. The questions again during the lecture. If you have questions, you can ask them again in our chat box, and I will see them here on the screen, and I'll try to answer them with Theo as much as possible. Theo, go ahead. Okay, thanks.
Well, the spatial impact of the energy transition, we did take a look at the Dutch situation, because that's the stuff I'm most familiar with, and I was involved in some studies connected to that as well. Let's take a look at what the energy transition in fact means. And we have four pathways, so to speak, and that has to do with the most difficult one is high temperature heat. Think about industry, transport and mobility, say electric cars, hydrogen cars. That's doable, and that's already starting. Lighting and applications, that's the easy part, and low temperature heat is the most easy one. Now, if you compare that to, say, the classic fossil fuel-based energy provision, and you want to move that towards renewable energy, then you see that requires much more space. To give you an example, a coal-fired power plant is very, very compact, reasonably small. Now, if you suppose you have a 1 gigawatt coal-fired power plant, say a few soccer fields in total in terms of area, and if you want to replace that by, say, solar panels, we need an enormous amount of solar panels. And the same is valid for wind as well. So it has quite a spatial impact, because fossil fuels is very compact, renewable, less compact. That's what this small presentation is about. Now, what are the plans for the Netherlands? We made an agreement that in 2030 we have about, say, 49% reduction compared to 1990 for the CO2 emissions. And that means we have to shut down coal-fired power plants, gas-fired power plants. We have to renew our mobility and our heating of houses.
Maybe just to interrupt a little bit, is that our renewable energy strategy is mainly based not necessarily on technology, but more on reducing greenhouse gas emissions, right?
The main goal is reduction on CO2. That's a unit of analysis.
Exactly.
And the means we have is renewables.
Yes, mostly. Yeah.
We could do, if we do all electric, and we pave the Netherlands with nuclear power plants, then we are CO2 free, but we have another problem. Okay. Now the strategy in the Netherlands is bounded in regional energy strategies. Every region has to figure out how to replace natural gas with green gases, so for heat mainly, how to replace fossil fuel electricity by renewable electricity. And our target is then about 35 terawatt hours on land in about 10 years' time. That's what we have to do. Now you can see the planning below that, but that's some institutional stuff. But the fact is that if we move over to renewables, that takes space. Initially, that was not really recognized. Everybody said, okay, we're going to do a lot of wind turbines, we're going to do a lot of solar panels, and we're going to do it offshore, and then it all bounds together. And then you can actually say that, you can actually do that. And then we started to think, okay,
where?
Yes. Because, you know, some people, many people, don't like to have a wind turbine in the back garden.
No.
And many people don't want to have a solar park, say, on the other side of the road. So then people start to think, okay, that takes a bit of space, this stuff. Now, what we did, we actually figured that one out.
Okay, well, sometimes also a more positive vibe, right? That, for example, your house, most people, I think, like it if they can put their own energy supply on the roof. but I recognize it's probably not enough, but that's maybe a good start.
Well, the roof is a good start. To give you an example, if you pave the roofs in the Netherlands with solar panels, you can barely meet the electricity usage of those houses, of say
Of the actual houses that you're
the actual
paving.
houses, domestic environment.
Yeah.
So you need much more.
Yeah, okay, but
We have these big yellow trains from the Dutch railways. They're about 1 megawatt. Well, that's a lot of panels.
Yeah. So you cannot fill that only by putting the solar panel on the train.
roof. Exactly.
No.
Okay, so we figured out how much space that we actually need, and what we did. We did take a look at, okay, suppose it's 2050, and what, in theory, if we want to meet all this renewable for electricity and heat, how much space would, in theory, we need?
Yeah.
If we use wind and solar PV for electricity, and if we use biomass and geothermal for the heat.
Okay. Yeah.
And well, this is our target in 2050. So we started to put the focus on the 2050, and then
nice direct line, eh? So
well, yeah. Whether or not we're going to meet that's a question. But we are well underway.
Yeah, that's true.
Yeah, so we're underway. Now, to give you an idea about units and numbers, and to give an idea on how much that actually is. Suppose you have 1 terawatt hour of energy. To give you an idea, the Netherlands use about 120 terawatt hours a year. Now, 1 terawatt hour, if you take a look at wind turbines, you need about 152 wind turbines of 3 megawatt. Now, one wind turbine of 3 megawatt requires 20 hectares. Now, 20 hectares, that's about 400 by 400 meters.
Yeah.
So that gives you an idea.
Significant chunk of land. Huh?
That's it. And it's a lot of soccer fields.
Yes. Yeah.
So, and if you take a look at for instance, a PV solar park, that's 1,600 hectares. That's also a lot of space. And now, how much houses? Well, 308,000 houses, 1 terawatt hour. Yeah. I'm not going to put it all there, but you can see that it requires space for 1 terawatt hour. We made the same calculations. We made the same calculations for 1 petajoule, and you get similar type of numbers.
Yeah.
So, and petajoules and terawatt hours are, say, the units for the energy.
Yeah, maybe just to come back a little bit, like we have this renewable energy strategy from the Netherlands. So we want to be completely, we want to make the target within the limits of the Netherlands. Is this also, how does it derive from? Is this target thought of by ourselves, or is it by the EU that said, okay, you in the Netherlands, you have to do this yourself?
No.
Or how does this come by? Maybe you can say something about that.
No, the EU directives do not say you have to generate it on your own country, your own service in your own country.
Okay. Yeah.
And if we see the numbers in a moment, it might not even be a good idea to do that. But the focus we had in this study is figure out if we do it all locally.
Yeah, if it's possible.
If it's possible,
yeah.
In theory, what amount of space do we actually need?
Okay.
Yeah. But it don't necessarily have to do that. Now, a big part can be done at sea. What you see here, there's quite some activities on offshore wind. And the roadmaps we have seen so far, say in 2030, we would have about 11 gigawatt on power at sea.
Yeah.
And substantial.
That is doable.
That's doable.
Last week
this is planned.
Yeah.
This is already planned.
Last week we had a North Sea energy lecture, and I think that is also apparent that there's much more competition even on the North Sea, but still there is space for this part.
Yeah.
If you only talk about electricity.
That's right. Yeah. Now, this is the study. This is a kind of a complicated sheet, and I would like to take you through it. But I cannot read it at this distance, so I have it in front of me.
No problem.
So what we did, we figured out there are two types of energy you need. First, you need heat to heat up the buildings, and secondly, we need electricity. Now, we split it up in heat, electricity, wind, and electricity, solar PV. And I'm not going to treat all those numbers, but if you take a look at the top table there, and that has a small notation with it. It says in geothermal. Now, drilling one well, that requires, say, about 1 to 1.5 hectares per location. And if you have drilled a well, and you can narrow it down to about half a hectare. But if you have 300 to 400 locations as planned in 2050, that's quite some hectares.
Yeah.
Now, that's at the point at the column at the right side.
Is this for domestic use or the geothermal, or is this more for example, greenhouses and things like that?
All of it.
All of it.
It is.
There's no distinction.
So it is buildings.
Yeah.
It is houses, company buildings, utility buildings, and greenhouses.
Okay, yeah. Because I think that the greenhouses are maybe the first. They're already applying it to a
they're
small
about
extent.
20 or so we already have, and after 20 we have only one is used for housing now.
Okay.
At this moment.
Yeah.
So now the biomass is you need to grow crops as well, so that requires a substantial amount of area as well, as you can see here. Now let's take a look at electricity from wind. Let's take a look at offshore. The distance between two wind turbines is about 1 kilometer.
Yeah.
And if we take the big ones, the 6 megawatt ones, they require about 100 hectares per wind turbine. Now, we will see in the next slide that we need about 7,000 to 10,000 offshore wind turbines of this size. That's a lot of area.
Yeah.
Wind on land is another one. There are 3 different. You can have near cities, you can have it on inner waters or industrial estates. In that case, we calculate with 3 to 5 megawatt size wind turbines, and it also gives you a substantial amount of space. For electricity, it's even worse. In this study, we took about 26% of the total rooftops of housing and buildings. And we already found that we need about 90,000 hectares as well.
Additional, or that is the rooftop area?
That's only the rooftop, and that barely makes up for all the usage of the houses.
Okay,
yeah.
but
domestic use.
But it's there already, so that's maybe a low-hanging fruit, right?
Yeah, a part of that is there already.
Yeah.
Currently, there's about I think 7 gigawatt on solar panels.
Yeah.
So we're well underway.
Yeah, but I mean, a roof is there already.
And the roof is there already,
yeah.
and that's not included in this calculation. So I excluded the rooftops from this one.
Yeah.
And I excluded the offshore wind parks as well. Now, to give you an idea, there's a rule of thumb as well. If you have a 1 megawatt peak solar park, that's about 1 hectare. So that gives you an idea how to calculate. Now, if you sum that all up, and take a look at the total size of the Netherlands and express that in hectares, about 3.4 million hectares on land and about 0.8 of a million on water, inner waters, then we can see down at the right bottom there that on land we need about 15 to 27% of the area for renewable energy, heat and electricity. For water it's 10 to 14%. Now imagine
a quarter of the country is covered.
Quarter of the country paved with solar panels or wind parks. Now this shows that the Netherlands is already quite a densely populated country. We need quite some roads and we have quite some agriculture.
Yeah.
So we need combinations, smart combinations.
Yeah.
And that's where the solution in fact lies. You could, in a combination, you could think of, if I have a wind turbine sitting somewhere, and below that wind turbine, I can easily have agriculture activities down there.
Yeah, I think that's for a certain extent already happening.
That's for a certain extent already happening.
Yeah, but maybe not everywhere. But,
no, but you could think of those of combinations.
And how about shifting more of this towards the North Sea, for example? Instead of thinking, we know that the Dutch government has a specific, well, at least a planned view on a significant amount of wind on land, significant amount of solar on land, and not, well, also a significant amount offshore. Yeah. Why not put everything offshore? Offshore, although it seems that there's enough space, it's busy there as well. Yeah.
It's, although you could, in theory, say you could put wind wind parks everywhere, offshore wind parks, but you're not allowed to sail a ship in a wind park.
No.
And you have seen, if we go back to this one, there's already a substantial amount of space which is located there. I agree, we could extend that quite easily.
Yeah.
And that's most probably going to happen.
Yeah.
Because you don't see that 25% of our space will be occupied of that space.
I think that's very interesting, because there are a lot of questions also beforehand from the audience, like what is it about public perception or acceptation of this kind of measures? I don't think it makes it very easy if you say, okay, 25% of the area of the Netherlands we have to use for energy.
Well, you see that happening now already. In the Netherlands, there was a target for 6 gigawatt on land for 2020, this year. We haven't met that yet.
No.
We haven't met that yet. And there's already quite some opposition against wind turbines. And that's understandable to a certain extent as well. If this wind turbine is turning around and you're sitting in the garden and reading your book and there's this flickering coming by all the time, that's not very nice. And so take at least put it outside urban areas.
Yeah, as much as possible.
And so a solution might be to move a substantial amount of, say, the planned gigawatts on land offshore to sea. But then we run into other problems. It's like how to get all this power on land, and we need other networks for that.
Yes, exactly. But this integration, you said, combining systems together, like solar roads, for example, or putting it in screens for the sound screens, for example, putting in PV cells there.
Exactly.
Did you look at that? Is that substantial enough?
And that's included. That was included in the study as well. But let's go back to this one. Take a look at solar PV along infrastructure, and that yields only 25 to 45 petajoules of the total. And you see, I put some hyphens there, because that doesn't require extra space. That's one of the smart combinations you want to do.
Exactly.
Now, if you combine along infrastructure, these solar panels, combine that with smaller size wind turbines, that might help as well.
Yeah.
Nobody really cares if wind turbine is on the road where there's not many houses.
Or PV cells or any other technology.
So smart combinations, that's why I put it there in red. Multiple area use, we need smart combinations for that.
Yeah.
Now, let's take a look at our this was the theoretical space we have. Now, let's take a look if we're going to realize it. What do we actually then need? And I left out the heat in here. I only focused for this one on the electricity wind onshore, and because offshore was out. And then we see that only for offshore, we need 7,000 to 10,000, 10,500 turbines of 5 megawatt. And on the last two columns, you see how much hectares you need in terms of space. Now, that can easily be extended, as we discussed before. So it might well be, and there will be more studies in spatial impact. It might well be that people think, okay, this is too much, takes too much of our space. So we're going to move it indeed offshore. If we're going to move to offshore, then we have a transport problem.
But that's maybe in terms of perspective or in terms of intrusion in your living space, it is maybe better.
And these transport problems can be solved. Because if you generate hydrogen offshore, put it in gas pipelines, and bring it onshore, and then you don't have to extend your electricity network, which with the 11 gigawatt is already filled up by 2030.
How does this relate to bigger turbines? I mean, I understand that they have higher diameters as well in the rotors, but in general, I think there's some kind of efficiency there as well. If they become bigger, that relatively speaking, they need less space. Is that something that you also take into account in the future scenarios?
This a bigger turbine provides more energy, because it's larger and it takes more advantage of the wind. But a disadvantage is that you need more space in between. Because they start hampering one another. So there's a trade-off, to a certain extent there's a trade-off there. But bigger turbines with higher efficiency, for offshore we calculated here with 6 megawatts, which is kind of standard now. But there's already one big one, 12 megawatt, which is going the Haliade. It's going to be tested onshore at this moment.
Yeah.
And so
They're thinking about 15 even.
Yeah, 15 to 16 would be feasible in a couple of years, but a kind of limit is around 20.
Yeah.
Then they become so big, and then we run into material problems.
Then you stretch of the materials. And also integration of technologies within these windmills, for example. You can do tidal energy or maybe other stream, make use of the water streams, for example, the tides going past the wind
Might
turbines.
well be if you have, but then you need locations where, say, this flow speed is high enough.
Yeah.
And so far, tidal energy was not very successful.
Mm-hmm.
So some companies tried it out.
Yeah.
They didn't really succeed.
Yeah, some countries also, Scotland, I think, and
in some locations
Norway.
It works, but there's only some specific locations, and just flow offshore on the open sea, that flow is not too high.
So you don't see that taking off. No.
Then it's probably cheaper to make your megawatt hours with wind turbines.
Okay, clear.
Now, if we then take a look at this sheet, then we see that in 2018, the total amount of wind turbines we have, that was 2 years ago, that's about 2,000, and we need 14 to 20,000 on land and offshore, and on land and offshore in 2050 to meet our requirements, and that is a lot of space.
That's a lot, yeah.
Well, similar for electricity. Currently, we have about 13 million of those solar panels on roofs, and we have to go to about 500 million, up to 1,000 million, and that also is a lot of space. So that's one reason more, just to say, okay, let's go into some very smart combinations to figure out how actually to reach that.
Because all this together would mean about a quarter of the country is full of this of these technologies, so to say.
And not only a quarter of the country, a quarter on land, and 10 to 14% on inner waters. Our lakes and our canals.
Okay.
And,
so floating solar panels, for example, or wind turbines. And
floating,
things like that.
floating, or wind turbines in say shallow waters.
Okay.
Which you already see now. So
so that's a significant challenge. Let's say that
that's a challenge, and so that brings us to a few of our problems. How to proceed now from this one? And so we first have to figure out exactly how much do we need in 2050.
Yeah.
But we have there are reasonable amount of studies which gives an indication for that. So the next step on what are the available sources by that time? Because what we didn't took into account in this study, because this was all geared to get it all fixed on home ground.
Yeah, exactly.
In our own country. Yeah. Now you might pop the question: is it necessary to do it all ourselves?
Exactly. Yeah. Yeah.
And
is it? That's the question. Yeah.
That's the question.
Should we not even pursue this? That's another one.
Yeah. Now, let's take a look at the current situation on fuels for cars. We don't use our own oil.
No.
And for decades, we were able to drive our cars happily around with importing oil. So why not import, say, hydrogen or more power?
Yeah, well, that links maybe a little bit to the Corona crisis as well, where we realized, to a certain extent, that having long supply lines of very diverse supply lines all over the world, maybe not necessarily energy, but other things as well, can be a problem. Making certain things or parts somewhere else, suddenly it's deregulated because of the Corona crisis, and we have a bit of a problem. Do you see that is also a reason why we feel more about domestic energy compared to international supply lines?
Of course, there's dependence in that sense, and there is a kind of a balance in what you can do locally. And with smart combinations, and especially with storage, you can be self-fulfilling to a certain extent. But we managed to have our economy booming, before the corona
That's
crisis,
true. Yeah.
to have a booming economy and optimized such that at reasonable prices we have all kinds of products. And that was valid for electricity or for energy as well. And as I mentioned, our fuels, we don't have our own production on fuels. We will shut down the Groningen field. And then we may, for say, a decade or so from the smaller fields, still have natural gas to heat up our houses. But in the end, we do away with that because we signed up for the Paris Agreement.
Yeah.
And you see that all kind of smart combinations now pop up. You see there's quite a development now in say certainly in rural areas for heating using ground source heat pumps, which can be used for cooling in summer as well at the same time, at reasonable prices. And then you run in the all electric house run into the all electric house. Another solution is say use our gas field, our gas network for other purposes as well.
For hydrogen, for example.
Research shows that whether you pump methane through it or hydrogen, it is feasible. You have to change a bit, you have to modify it to a certain extent, but it's feasible. And you see now all kinds of equipment coming onto the market. Even I learned last week or 2 weeks ago that there is a heating boiler from Bosch in the UK, Worcester, and that runs on natural gas and on hydrogen.
Yeah, you can switch or something.
And you can switch or can even make a mix. So you see that the technology development is going to help us here as well.
Yeah, so technology on the one hand, but also like we mentioned, also with the larger wind turbines, for example, or the spatial integration of these technologies, but perhaps also a widening view. So instead of doing only the Netherlands as a single country where you have to do it all by yourself, perhaps you can look at Europe or even outside of Europe.
Yeah, even outside of Europe.
Where have this better integration of energy.
And hydrogen is a good example. As hydrogen is pretty expensive now to make it here with electricity. Green hydrogen with electricity, with electrolyzers. But the major part, about 75% of those costs, production costs for hydrogen, is electricity. Now, if you go to a country where this green electricity, for instance from solar, is cheaper than in our case, if I have a solar panel on my roof, it can provide a certain amount of electrical energy. If I put that same solar panel in the Sahara, it provides 3 times as more energy. So it is obvious that it's more cheap there. So make the hydrogen over there and transport it, either via tankers. We do it with LNG all over the world. For hydrogen, it's a bit more complicated, but not
it's doable.
The first hydrogen tanker has already been released in December last year.
In Japan.
And we can even use our transmission gas network to transport that hydrogen. Well, make the hydrogen where it's cheap.
But there's also, I mean, to give it back a little bit, I realize the technical and the economic perspective, but the geopolitical perspective may be in between. Hampers you a little bit of thinking about this. These countries are not always the most stable. So do we have to fix that first then, and before we are going to...
It can help. It can help if you bring in North African countries, if you bring this technology there, and they not only provide us with hydrogen and energy, but they have energy themselves as well. So that
development energy
that feeds economic development. So you might help developing an economy in those countries, which takes away the pressure of migration. So these are quite complicated things, but there is a positive sign on it.
Could this be an aspect of the Green Deal in general, but also more of specific to the Corona crisis, where we have this money available, or at least it's being pumped into the economy to save it to a certain extent? Can we use this? Would this be a requirement even? Do you want to put this in as a requirement?
Well, I think it was already planned before the Corona crisis. These ideas already existed, and this generate this energy, hydrogen, or can also be ammonia
Yeah.
locally, or it can also be methanol, but whatever you want, artificial methanol. It's just, whatever carrier you want to move into it. And so the idea is to bring it in primarily North African countries, was already there before the Corona crisis.
Yeah.
Now the Corona crisis even puts our nose on the lid that we really have to take a look at it. And so never waste a good crisis, I would say.
Yeah, exactly.
And
Yeah.
try to get the best of both worlds.
Yeah.
Helping over there and also solving our say sustainability efforts,
Yeah.
meeting our sustainability efforts.
Yeah, because maybe using more a global or European perspective of solving the energy transition can also help perhaps for our domestic favorable conditions for that people accept this transition better. I mean, if I see your figures, it has a significant impact on how the Netherlands looks right now, how it will look in the future.
Yeah.
So public acceptance, do you think it will help if we look at it more from a European or a global perspective?
I'm convinced that it will help. It is cooperation is the foundation for economic development worldwide.
Yeah.
So I think we have to go that way.
Yeah.
And so it will relieve our spatial impact. And suppose we can heat up our buildings for 50% with hydrogen, and then we don't need in the all-electric version. We don't need all these wind turbines or these solar panels to feed these heat pumps. By the way, in winter there's very little solar and there's less wind. So we have to do some smart stuff with storage.
Yeah.
But we do have an infrastructure, which is the gas infrastructure.
Yeah.
So why not make sure that we get this hydrogen over here and say put half of these houses onto hydrogen heating, making use of our gas infrastructure. We know the technology is there. It's affordable and it's feasible as well.
Yeah.
I'm not sure how expensive these hydrogen burners are because I haven't seen prices yet.
No, it's quite new.
If you see the design, the size is about the same. And if you see this hydrogen natural gas boiler, which is now built by Bosch in the UK, and we will see more of these developments.
Yeah.
So try to utilize your infrastructure as best as you can, which you already have, and try to avoid 25% paving of the land surface in the Netherlands with solar panels and wind turbines.
Yeah, also because in general it is significant. Well, our country is small, so it's already expensive. Also, land in general, so you would raise the price of that as well.
Yeah, that's
of this energy transition.
So
compared to Sahara. Yeah.
Local optimization would be a good idea, and international cooperation would even be a better idea.
Yeah, exactly. Yeah. Okay, very interesting. Yeah, so what you're saying, I think it's great also relating to the more developing countries to say, okay, maybe we can help them out. I was just wondering, what is happening with the study? Is this being used to a certain extent by the government to say, okay, let's change our perspective on the renewable energy strategy, or?
Well, this study was done in the light of our new legislation. Around the environmental vision, which was set up by the government, and we used available data, available reports from the Programmabureau voor Leefomgeving, which is all public information. And what we did, we simply calculated and figured out how this matches the total area in the Netherlands, and that of course has an impact on the environment, and therefore it's a part of the environmental reporting on the impact of the environment. So this study. So it was done already, and it's not yet freenet as far as I know.
Okay,
but our advice will. I'm a part of this committee. Our advice will come out somewhere in June, I suppose. But I already learned last week that there are other research and other engineering companies who carried out similar investigations. And I haven't compared the results we have with those results, but I would guess that it would be in the order of magnitude in the same direction.
Yeah. So you haven't compared them yet, but do you know of any other of these studies that have been done in other European countries, for example? Is this a similar? Maybe you rephrase the question. Is this a similar discussion in other countries? spatial impact?
Not to my knowledge. I know a bit on Germany, but I haven't sorted that out yet.
Okay.
So we will take a look at that.
Yeah.
But I would reckon that similar questions would rise as well.
Yeah.
We know also from Germany that there is a bit more opposition now against wind parks. And although Germany has very big
areas,
bigger areas than the Netherlands, it's less densely populated, and they also have a policy on renewables from the 90s already. And you see bigger solar parks and wind parks than we see in the Netherlands. So I think they're a bit further on the road in renewables, substantially further on the road than the Netherlands.
Yeah.
But I expect...
But even there's some opposition going on, or the same questions are being asked, like how to deal with this.
Yeah.
But yeah, maybe that's then a follow-up question. If we think about it in a European perspective, do we get the problem that all these technologies are being placed in areas where there's less population already? So, for example, we in the cities or in highly populated areas say, okay, we don't want this. Let's put it in a rural area where almost nobody's living. But I can imagine that those rural people over there are also not that happy about that.
No.
Do you think that's a risk in this situation? That
yes,
we move it away
there is,
too
but
fast?
this development, you already see that.
Yeah.
You don't see wind turbines in inner cities.
No, true.
Not only for the fact that they have less yield over there. So you want to have wind turbines on the places where you have wind, and that's most of the time in rural areas. So you see that already. But also, if you cannot pave the rural areas either.
No, of course, no.
Yeah.
No, but I can imagine that with a little bit with the populism going up as well, that there's some anti-feelings in that. That you say, okay, the rich parts of the country are shifting the problem to the maybe less rich part.
Well. As I said, you can wind parks can be very nicely combined with agriculture, and that's what you already see happening. Yeah, and you can intensify that. Yeah, but there is a limit on that. At a certain stage, people would say, okay, there's too much wind turbines here. We don't like them anymore. And if you run into that boundary condition, then it might not be a good idea to put even more wind turbines in there, because 6 megawatt wind turbines requires about 50 hectares. That's a lot of crop you can grow underneath it. Yeah, but if you're already using that, if you're already making crops, then of course there's no problem. And if you run out of space, you have to do something else. So in that sense, you might even think of nuclear. Nuclear is also very compact compared to.
This is a bit of a hot topic.
Coal-fired power station and a gas-fired power station is about the same size, but there's an important issue there as well. The infrastructure to put all this power onto the network is already there. Yeah. We can see that in France, right? That's already there for a large part. Well, but do you see a future for nuclear in the EU or the Netherlands? I see a future for nuclear. Yeah.
Because of the spatial impact.
Because of the spatial. No, partly because of the spatial impact, because it's small, but it doesn't emit CO2.
Well, and locally, yeah. Yeah,
well, locally, indeed, locally, but also if you uranium production, if you can do that, say in a low carbon manner, for instance, hydrogen-driven digging machines and that kind of stuff. Yeah, then it would work. Yeah,
and disposal of waste?
Disposal waste that's still, you have to do something with that. Yeah, that's true. Yeah. But you should not over-exaggerate that. These things are pretty compact. And in the end, if you take a look at the long-term future for nuclear, then on the verge. But we have on the verge already for decades. The fusion machines. But there's a big one now being built, and experiments are encouraging. Still, a lot of things have to be solved. But if we wait a few decades, that might solve us all. But I see a role for nuclear because this technology is already developed. And it's pretty safe. Yeah,
and stable days as well. Stable production.
Stable production, and we need. There's no intermittency in renewable, and there's intermittency in wind and solar. Yeah. If we do everything from wind and solar, we need an enormous amount of storage and conversion. Yeah. Now, what would reality be? a big part, renewable wind and solar. A substantial part of that will be conversion and storage. And I see a role for nuclear as well, because when the sun doesn't shine and the wind doesn't blow, and you have that for a couple of weeks, you need an awful amount of storage and conversion, and that requires space as well. So I think it will be a kind of mix. Which mix we get? That's a matter of scenario. Figuring out what would be the most ideal one for this area.
Yeah, but maybe is time not ticking a little bit in that sense? Do we have to? There are so many options. There's so many different characteristics of energy carriers or energy production systems. Sorry, when do we have to make a choice? Because these policies continue by themselves as well. Like wind parks on land, wind parks on sea, solar on the rooftop, solar somewhere else. So these things have an organic development. But we also have to make a choice. We have to design the system.
Well, you cannot make a choice on stuff you don't know. That's for so. Yeah. And 2050 is a scenario now. What you can do, however, is if I have, and that's the stuff the guys from the energy transition model, the Quintel guys figured out. They said, let's take a look at the corners of the playfield in 2050. What options do we have? And then you can figure out maximum of this, maximum of that, and then figure out, and then if we calculate backcasting to now, what would be good decisions to take now, and take it step by step.
Yeah.
So and that indeed would be my suggestion as well.
But have we done that already? Is that the basis of these new the Green Deal of these new energy strategies?
The reports I saw 2 weeks ago, they point into that direction. And they were carried out on behalf of the ministries of the Dutch government. So they are certainly thinking about it. Yeah. They are making use of the tools we have. The energy transition model is a very nice one. We have many models, and it's about 20 or so. Yeah. And so people are really thinking about this future. And every time there's a new development, technology development, which may help, then you can redo those scenarios and adapt them to the insights you have on that and at that moment. Yeah. And based on that information, you can figure out policies.
Yeah, but that's a very complicated puzzle, as we've all seen, because they change as well. Yeah. For example, 10 years ago, nobody would have thought that hydrogen would probably be such a big role in our energy system.
Well, I know of a few people who thought about that 10 years ago.
Yeah, but they were maybe then in the minority.
Yeah. It's moving on now. Yeah.
Yeah. I have a nice question about waste to energy. Is that because you mentioned biomass also with imported biomass, but the waste to energy, is that something we can count on?
Waste to energy was included in the heat part, but it's not on our sheet. Waste to energy, as we use it now, it's okay, but it's already not that much. And if we're moving into, say, the circular economy, we get less and less waste because we're going to reuse a lot of these materials. Yeah. And burning them up for heat or for electricity would be then, would be the kind of a last resort. So, and if we move more towards sustainability, and circularity is a part of that, reuse of waste, so there will be less waste. Yeah. So in that sense, there will be less energy based on waste. Having said that, there is quite some waste heat from data centers. And that can be substantial as well.
Okay, from data center, but they require electricity as well. So it's a bit of a...
Yeah. So a part of the waste energy we have now in burning up, say, waste we collect from housing, that's going to be replaced by, say the waste heat from data centers. Yeah. But on that, having said that, that's the current day technology. Yeah. So that's a silicon-based electronics we have in there. If we move to optotronics, light-based electronics, they don't become that hot. We even have to cool them down to make them work. But then we might not. So technology might be further on the road that we don't have. We cannot to make.
You cannot count on it. Basically.
We cannot count it to make it too short. In short, we cannot count on waste as, say, a renewable source.
Yeah, true. So, but you can, if you have it, use it. But if not, it's not a strategy in itself.
No.
It's no.
And then I would rely on the real renewables, like wind and solar, and the carriers like hydrogen and batteries. Yeah.
Maybe to come back a little bit towards the planning issues of this transition, or at least how to do this. Is it more? What do you think? Is it better to do a top-down approach where a government says, "This is the dot on the horizon. We have to go there," and we select certain options, and we go for it? Or is it better to do it from the bottom up, saying, "Okay, we create a climate where you get a certain amount of money for your kilowatt hour or your heat requirements or whatever, and we let the market figure it out"?
Well, that's basically what we're trying to do now, with the regional.
One.
Yeah, the second one, the last one. So, but it's a combination of the top down and the bottom up.
Yeah,
like the regional energy strategies. We have installed. We have started up in the Netherlands. They were initially were sorted out top down, but say the actual operational part is a bottom up.
Yeah, okay.
And in the meantime, we learned. Placing wind turbines, take the inhabitants living around the wind turbines, take them on board as early as possible in the process. So it without a bottom-up approach, the top-down is not going to work.
No.
So it will be from two directions.
Yeah. So there's some higher strategy, but not really filled in, because you also want to make use of the technology that is available, or the new technologies under development, I would say.
Yeah.
But taking the inhabitants with you, yeah, that's all nice. But do you also want to take them into the business model, for example, of these?
Yeah, I think you have to. I think you have to. There are examples already that acceptance and acceptability on wind turbine, placing wind turbines was successful in various locations in the Netherlands, and that would be so if you own a small part of this wind turbine, and
it feels better.
It feels better. That's one thing. But also, if you get money from it, then that will help.
Yeah.
And in the end, energy provision is a community thing.
Yeah.
Everybody makes use of it, but also everybody is involved with it.
Yeah.
So say the governance model will be a combination of both top down. For rules and regulation and directions, and that's the dot on the horizon. There's blue sky vision, but also taking on board the users and the people who suffer from it.
Yeah, exactly.
At the same time,
yeah.
and to make sure that the acceptance for meeting this 2050 goal of 95% reduction, read low carbon economy.
Exactly. Yeah.
It needs to bottom up as well.
Yeah, because that's the main thing. I think, depending on if we look at more traditional forms of energy, at least where they're being mined, for example, that is not always the most logical that you take everybody on board.
No, that's true.
And with this renewable energy strategy, you could say, okay, don't make the same mistake. Make sure everybody is on board.
And specifically, as we have seen in this discussion, the traditional way of generating energy was very compact and needed not that much space.
No.
But if we move in, say, the renewables, requires much more space.
Yeah.
And that's going to hit a lot of people.
Yeah. Yeah, so we mentioned the magic word, which is nuclear. So there are some questions coming in on nuclear energy. So I hope you still have you want to answer those. Is it maybe not better to, if there's so much promise in nuclear fusion, for example, isn't that not better than to put all the R&D money on that?
Well, there is already a substantial amount of R&D money going into that. So the ITER, which is the nuclear experimental reactor, which is built in Cadarache in the south of France at this moment, it's actually being built. Requires a lot of money.
Yeah.
You're talking about 10 billion or so. So that's a lot of money. But the possible reward is enormous.
Yeah.
Suppose this works. It doesn't work yet, but suppose this works. There is no waste problem. Well, very, very little waste compared to, say, the classical nuclear.
Yeah.
But also there's no... you cannot make bombs from it. And
maybe some people have problems with that, but
and
most people don't.
Yeah, well, there's no proliferation problem.
Yeah, that's true.
And it cannot melt down. It cannot melt down. There's only a few kilograms of hydrogen and helium in there, and as soon as the temperature goes down, the process stops.
So is there any risk associated with it, similar to nuclear?
No.
Nothing at all. No. Okay.
The only risk we have is it is technologically spoken from an engineering perspective. It is really, really complicated to do that.
Yeah.
Imagine you have to heat it up to say 100 to 150 million degrees to actually make it work.
Yeah.
And so we haven't succeeded yet in the research to keep that ongoing for say for a second or 2 seconds.
Okay.
And it should work, 24 hours a day.
Yeah.
So
so that's a drawback, actually.
A big part of the physics is understood already.
Yeah.
A big part of the quantum mechanics is understood. Not all of it, but the technological challenge from an engineering perspective is enormous.
Yeah.
But the reward is also enormous. So to answer your question, we're already throwing a lot of money onto it. And a nice thing is everybody is involved worldwide.
It's very under the radar, I think. It's not something that, you have in the newspapers about hydrogen, about the wind parks, about solar parks, about strategies, etc. But you never hear, or you very little hear about this technology.
That's because it is not going to work yet. It's not working yet, and it's still in the early development phase.
Yeah,
and I remember in the 80s, even earlier. When I was studying, they were mentioning, in the 90s we will have a fusion reactor. Now it's 2020.
We're still
and
building
first
it.
plasma in the ether is now planned in about 5 years from now. So that shows how complicated it is. But
again, the rewards are huge.
The rewards are huge, and we're basically mimicking nature, because what's happening in the sun are we doing downstairs on Earth now.
Yeah.
The only problem is we don't have the gravity here, and so that means that we have to pull off all kinds of tricks to make sure that this fusion actually is going to happen, and that we can extract the heat and the energy from it.
Yeah. But in general, it is a good. But it's still 30 years from now.
Oh, maybe even
maybe
more.
50, 60, 80, whatever. Yeah.
There are still a lot of technological, but also theoretical problems to be solved. But
even throwing in a lot of extra money will probably not significantly increase that pace.
It's like human reproduction. Huh? And an economist would say, okay, I have a woman, and I have 9 months, and then I have a kid. Okay, I put 2 women, 4.5 months kid. It ain't going to work that way. And
that's
the stuff we're doing with fusion research is a similar thing like that.
It's very hard to accelerate.
Many smart people are working on it already, and there are a couple of hundred PhDs on it a year.
Yeah.
So there's all the brains we have in humans are already working on it.
Yeah. So we just
but it takes its time.
Exactly. We'll keep them working, and then hopefully. But although it doesn't solve the problem we have in the next 30 years, we still have to do that with the conventional technology.
But if you take a look at the far side, I'm quite optimistic on the future. Because in the base load, we will probably move from fission nuclear to fusion nuclear. Let's say the current nuclear 4th generation reactors to the fusion for the base load. And for the rest, we're going to do it with wind and solar. And very smart conversion and storage. And there's a substantial role for hydrogen there.
Yeah. So that is basically your future scenario.
That's the kind of ideal scenario. The ideal scenario I'm envisaging here.
Okay. Very nice. One more question about nuclear. The waste you mentioned, it is substantial but not enormous problem. Is it spatially also a substantial problem?
No, it's quite compact.
It's quite compact?
But it's dangerous. You have to be careful with this stuff. And there's also ways to make sure that there is a way to treat that waste. The only problem is, it's called transmutation. The problem is it's expensive. If we move over to thorium, from uranium to thorium, and that might be another option as well, because that's shorter living waste as well. You don't have to store that for many decades, for many centuries, so to speak.
That makes it a little bit more doable.
But there is no development on thorium to date.
Well, a little, exactly. Yeah. Okay, there was one more nice question I want to give you, is that the current crisis also generated a loss of demand for oil. So there's less oil being used at the moment. So that creates a lot of problems in the oil industry, but it also makes gasoline cheap. Is that a threat to these renewable technologies? Or do you think it will backlash the other way around?
Well, the renewable
or at least the development of the implementation of the renewables.
Well, of course, if you run your car on gasoline, and gasoline is cheap, then from an economic perspective, you wouldn't run a hydrogen car because that's more expensive.
Yeah.
You know, a kilogram of hydrogen is about 10 euros now. But that's based on the gasoline prices we had a couple of weeks ago or a couple of months ago before the corona crisis. But there's another thing on cheap gasoline. There's a limit in 2050 because we said we have to cut down on the CO2 emission.
Yeah, so that stays. Yeah.
And so at a certain stage, and it is simply not possible to do that anymore because as of 2030, a significant amount of European countries simply prohibit bringing internal combustion engine cars with an internal combustion engine onto the market.
Yeah.
So by that time, it should be either fuel cell or electric.
So maybe on a very short term, you have an advantage perhaps, and maybe you have a little bit of a slowdown in the renewable technology implementation. But you also mentioned before we started this conversation that the backlash can be if a lot of people fall over in the oil industry that there's no investment in the current oil supply. That means that it becomes very expensive actually. Yeah. When demand slowly recovers.
Takes up again.
Yeah.
Because there are many gasoline cars driving around. In the Netherlands we have about 8.5-9 million cars. Mm-hmm. And about 120,000 of that is electric.
Electric, yeah.
And only about, I think, 120 or 140 of that is fuel cell.
Yeah.
And the rest is battery or hybrid.
Yeah.
So the majority
is still internal combustion.
Gasoline. So the gasoline is here for a while.
Yeah, exactly. But you will get a backlash of that actually. So it becomes a lot more expensive in the end, prohibiting. We don't want to be exposed to that perhaps. So it can also be an opportunity for renewables to be quicker in the implementation.
Well, and another is the development on the electric cars. Mm-hmm. You see that electric battery cars becoming cheaper and cheaper.
Yeah.
And at a certain stage, you will see that there is in the near future, and that has to do with the technology. A gasoline car, an internal combustion engine car, has many more moving parts than a battery car. So, and at a certain stage, the battery car is cheaper in maintenance, but if you produce enough of them, because it's simpler, less moving parts, it's also easier to build.
Yeah, so it even outcompetes at some point the internal combustion engine.
In the coming years, we will see that battery cars simply are cheaper than internal combustion engine cars.
So
it's the economy which
exactly. It's the economy and the technology that sort of decides the issue. Yeah.
And if we then see that the battery development double or even triple, say, the capacity. Yeah. I have an electric car which can run about 400 kilometers with it. Mm-hmm. And if that triples, if I can, with the same car, and it becomes 200 kilowatt hours on board, and I can have 1,200 kilometers on one charge, who cares?
Yeah, exactly. Yeah. Okay, good. Thank you very much.
Okay, you're welcome.
We're running out of time. I think it's great to what you mentioned, that this more of a European view is something you have to consider, or world view in the spatial distribution of energy technologies. Perhaps with the base load of certain other technologies like nuclear, to keep it all going together with hydrogen. I think that's a very nice view to the future. So thank you very much again for joining us in this webinar. Next week we'll have another webinar together with Nijrode and also with the Energy Academy about breakthrough technologies development. And 7th of May we all have a week off, so also with the webinars. And the 14th of May we'll have another hydrogen webinar, because we had lots of questions about hydrogen and lots of discussions. So we do this together with Hydrogen Europe, and so join us again also there to learn more about the hydrogen potential and impact on the energy future. So thank you very much, and have a great day.